Okay, here I have 8A. 8A, I'm not going to talk about it. You just need to memorize the characteristic of image. Okay, so you have a lot of these image characteristic. Basically, it's always virtual versus real, upright versus inverted. This one is meant for mirror only. Okay, literally inverted. Please don't tell me that it is an image characteristic of a lens. Okay, don't need to do that. This is just for mirror. So for lens, there's one more that is your whether it is upright, whether it is diminish, or if it is same size lah. So of course for mirror it will be same size. Some of you are asking me, oh sorry, I make a mistake. It's not upright. This one is magnified. Sorry. So it is magnified, diminish, or same size. So can you write gets bigger, gets smaller? Unfortunately, no. We only want words like magnified or diminish or same size or not. Can? Okay, for part B, it is about reflection. So this one is tricky in a sense that they didn't give you the object. So normally they will give you the object and then you must measure. Then after that, you go and draw your ray and so on and so forth. But this time around, we give you the reverse. So what you need to do is quite straightforward. Just draw the ray first, lor. Since you do not know what is going to happen, right? You just extend the line now. See what kind of conclusion you get. So you see that these two rays must come from the same virtual image, right? So this is basically that virtual image that forms. And this virtual image must come from somewhere, right? And you know that in reflection, the biggest law is that your object distance must be equals to the image distance, right? So here you already found your image distance. So get your image distance over here. So this image distance must be equal, right? So for me, I will just do a copy and paste. Then I know that it is confirmed the same already. Yeah, like that. For you, you have to use ruler lah. Then I will find that, oh, okay, this means that this is my object. And once I know this is my object, right, then I just need to link, right, this ray over here, right, this black darkened one has to come from the object, right? The light has to come from the object, right? So I know it is from here. Then same thing for this guy. It has to come from the object, right? So I know, no, done. 3 mark, just like that. Okay. Now, if you are still having some trouble with this, please come and approach me. Do not go into the exam center with the mindset that, hey, I'm weak in mirror. I hope the setter will not set mirror. I tell you, flat hope. Set 3 only half the syllabus. Everything in the syllabus will be tested. There's no way you can select question. Because we don't have enough content to actually fill up the 80 marks. So definitely we will test every aspect of your syllabus. When you reach set 4, there is a chance that some of the content will not be tested. Set 3, confirm every bloody thing is tested. You cannot escape one. So if in your mind you know that, oh, I'm weak in this, you better go and figure it out. Or you ask your teacher to teach you. Okay, question 9 is another light, so I will include this in my video. So when you have a light question, you need to know how to draw the normal. So for example, in this case, they are asking you why there is no change of direction when the ray enter at Q. So you refer to here, this is the ray that enters into Q, right? You can see that there's no change of direction. It's like it is passing through the thing. So why? The reason is, whenever you do light, right, it is very, very important for you to be able to locate the normal. So this is your normal, right? Then you may ask me, teacher, what is this blue line? How come your one got the blue line? This is because this is a curved surface. So when you have a curved surface, you need to be able to draw the tangent. The tangent will represent the boundary. Like if this is a block of glass, you shoot the ray in like that, right? So that tangent basically helps you to analyze the thing. And of course, once you know the tangent, you can draw the normal over here. So what do you see? Can you see that the light ray and the normal coincide? They are on the same line. So actually down here in this case, your angle of incidence is equals to what? How many of you write 90? No, angle of incidence is between the ray itself and the normal. So here you can see this is the ray, right? The red color one. This is the ray. Where's the normal? The normal is this green one, what? So what is the angle between them? 0 lor. So you need to tell me that the angle of incident is equals to 0. Now can you write this way? No, you cannot. You must spell out the entire thing. And 0 degree. Don't forget the unit. So because this is just one line, one mark, you can just say that, oh, because it is angle of incident is 0, so therefore your angle of refraction will also be 0. So by the way, this one is refraction. But what if it is two line? What if you need more detail? Well, in physics, when you are asked to explain something, right, the shortcut is always to use formula. So you can write because. You cannot use this because you must spell out the full because. So because incident angle is 0 by n1 sine theta equals n2 sine theta, right? Your angle of refraction will also be 0 degree. So it will cut through the block without turning, right? Next thing, you need to also know how to apply Snell's law. Okay, Snell's law, very easy to do. What you need to do is you need to identify which side. So this is air and glass. Do the same thing over here. Air and glass. Now one thing you need to know is that you need to memorize what is n of air, which is 1. Then after that, you need to ask yourself, what is this theta here? Well, the theta is basically the angle in air. In this case, the angle in air is 0. N of glass, it is what we want to find. Then what is this theta over here? Well, this theta over here would be, would be what? Would be 0 also. So I'm stuck, right? Because sine 0 is 0 and ng will be 0. So I will be stuck. Then what to do? Raise your hand and ask the invigilator, is the question set wrong? And then what if the invigilator reply to you that, hey, please read carefully. So if you get the thing, please read carefully, maybe you need to read carefully lah. So we have analyzed the boundary here, right? Air and glass. We didn't analyze this, right? So now, since I know that this part between this and this, it won't work, let's analyze between this and this. So if I analyze this and this, first thing you can see that I already know that this is 90 degree, the angle in the air, right? I say that the angle that we are analyzing is always between the ray and the normal, right? How about the angle in the glass? Well, again, it is between the normal and the ray. So we are talking about this angle, which is 40. So once we know that, we can modify our Snell's law, right? The angle in the air will be 90 and the angle in the glass would be 40, and now we can solve our equation, right? If you press the calculator, sine 90 is 1. So here you will have ng sine 40. So go and solve the equation and you will be able to get your value here. Remember 2SF. Yeah? Okay, then for part C basically it's always asked this question will come out one. They will ask you to sketch. That means they are asking you to predict. They want to check whether you can predict or not. So when you see that the light come from a glass, that means high index to a low index, right? You must check total internal reflection. Okay, so how to check? Okay, you need to go and find the critical angle. Okay, if the ray go from a high index to a low index, you need to check for this phenomenon called TIR. So how to check for TIR? Basically you just imagine you need to find the critical angle. Why you need to find critical angle? Because that is like the value that you must compare to figure out whether the light can exit the glass block or not. So what is critical angle? Critical angle is basically when you shine a ray like that, if it is at critical angle, the light will go like this. So you can use this as a template to get let's say this is air to substance X, okay, or substance X, okay, substance X. So how to find the critical angle of substance X? Well, critical angle of substance X will be when the ray go from substance X at this particular angle called critical angle, the resulting ray, I use green, the resulting ray will go along the boundary. So I will get something like this. So if now I solve my equation for C, I will know the critical angle of substance X, right? So, but this question, they are very kind to you. They already tell you that this is my critical angle for this particular glass block. Now you have a ray whereby the angle of incident is smaller than your critical angle. So when this happens, basically you will get refraction. So your red color ray will go out and it will bend towards the normal. So it will bend this way. As long as it is towards the normal, you will get the mark. Okay, so you may ask me, teacher, what is this dotted line? Well, this is my original ray lah. Okay, for me, I just want to draw it because it helps me to check my paper, right? I will know that it is bent towards the normal, right? This is my normal, correct? So that's one. If you continue and look at your part D, right, you will see that for part D, you can see this ray go like that, and then after that it goes this way. That means what? That means this particular angle is already my critical angle. And now they're asking you, now I shine a ray like that, and my angle of incident is this. So you can see that now your angle I is basically larger than your critical angle. And when this happens, basically you will have total internal reflection. This thing, reflection. So it is like a mirror like that. So what you need to do, just reflect all bounce back, like that. Okay, please measure this angle and this angle have to be the same. Alright, so that is your light. Oh, describe what happens to this ray. So describe what happened. Total internal reflection. For you, you need to spell out. You cannot use short form like that. Sometimes they may also ask you, can you explain why TIR happened? So how to explain why TIR happened? The easiest way is that you explain the condition for it to happen. So what are the conditions to happen? Well, condition number one is that your light, right, must travel from a high refractive index to a low refractive index. By the way, this one is short form. You cannot use in exam. You must spell out. And then number two, the second condition is that the angle of incident must be larger than your critical angle. Okay, so beware of this. And since we are revising on light, right, your Snell's law, this thing is not the only formula. For your light, there is another formula. If you forget, that other formula is N equals to C over V, whereby C is the speed of light in vacuum, and V, basically this is your speed of light in whatever medium that you are analyzing. Okay, and of course this is your refractive index, and refractive index no unit.